Electronic affinity is another property that tells us how easy it is for an atom to form an ion, and in this case a negative ion, and we call these anions. So electronic affinity is defined as the energy liberated when an element in gas phase gains an electron and becomes a negative ion, an anion. So it's energy liberated when your element goes from being an element, a neutron element, to an anion, a negative ion, and it's defined one electron at a time. And in theory, you can make, you would gain one electron that could get another electron and then another electron, and in theory, you can predict theoretically loads of different ionization, electronic affinities. So again, I'm going to ask you to stop the video and have a think. What will liberate more energy? If your element is small or if your element is very large? Stop the video now, please. If I think about the size of an atom and what will liberate more energy, hopefully you can see that the smaller the atom, the more energy will be liberated, because that electron will get into the electronic cloud and it will be closer to the atom, and it will be closer to the nucleus and much more attracted than if you're in a larger atom in which the electron still goes to the electronic cloud right at the edge, but is less attracted by the nucleus. So the smaller the atom, the larger the energy is going to liberate when it gains an electron. So if I compare, and I go to this side of the periodic table on purpose, fluorine and chlorine. Chlorine is much larger than fluorine. We're talking about 17 electrons or 17 protons instead of 9. When fluorine gains an electron, that electron is going to go closer to the nucleus than when chlorine gains an electron. So yes, it's still energy liberated, but it's a smaller amount. So if I think of two atoms, for example, let's pick fluorine and chlorine is larger than fluorine, and I think of both of them gaining one electron. Well, the electron in the atom of fluorine will be closer to the nucleus than the electron that goes to the atom that enters an atom of chlorine. So the amount of energy liberated when the atom of fluorine gains one electron will be larger than when chlorine atom gains an electron and becomes negatively charged. So the smaller the atom, the closer that electron will go to the nucleus, and the larger the energy liberated. So in a group, because the smaller atoms are at the top of the group, electronic affinity will increase as we go up the group, because the atoms become smaller and therefore the energy liberated will be larger. The more we move towards the right in a period, because the atoms again become smaller and smaller, then the more energy will be liberated. There are certain exceptions, like for example the fact, helium here in the corner, although it's very small. Well, hydrogen again, because it's very special. You're talking about electrons that go into a 1s orbital. There's a lot of repulsion there. There are quite a lot of considerations that happen with hydrogen, and helium does not react at all. It doesn't have any compounds, because helium has a perfectly stable outer shell, is complete, it doesn't have any need to react. So the atom credited with having the largest electronic affinity of all the atoms of the periodic table is our friend fluorine. Fluorine has a huge tendency to gain an electron and become negatively charged, because it's a very small atom. So the smaller the atom, the more energy liberated when an electron when that atom gains an electron, with a couple of caveats about an atom that doesn't react at all, helium, or a hydrogen that reacts in a quite a peculiar way, because being so small that the general periodic properties don't quite apply to it in all cases.